Hi guys, welcome to part 2 of the mock exam algebra run through. Today I'm going to go through the last two parts of that first question. So let's just get straight into it. So Auckland City Councillors are extremely concerned about the capital expenditure for the infrastructure of basic services to meet this population growth. They have determined that they can sustain the growth provided Auckland's population does not exceed 3 million. Okay, so this information's what the only part that I really care about. Determine the maximum rate population growth for the budget not to be exceeded. So, the question's asking us to find the rate pretty much by when it, by when it hits 3 million people in the year 2100. So, if we go back to the question above, we have this equation that we can use, and we can rearrange it for b. B is just the rate. So I'll write that equation out again. Pt equals a b to the power t. Now we're trying to find b now. This is also r. We'll just call it r so it's easier. So this a, that's still going to be the 1.7 million. Okay. This PT here will now be this future population, 3 million. So 3 million. The B, we're just going to call it R. We don't know what that is. That's what we're trying to find. And the T, the time. So now it's not the year 2035. It's the year 2100. So it's going to be the difference between this and 2022. Because that's the equation that it's based from. So it's going to be the difference between 2100 2022, which is 78 years. So that's going to be 78. Okay, now we have an equation that we can rearrange and solve. So the first thing I'm going to do is move this 1.7 million to the other side. So it's going to be 3 million divided by 1.7 million equals r to the power of 78. So now it's literally just r equals the 78th root of 3 million over 1.7 million. Sorry, it's a bit messy. And that actually simplifies to 50 over 29. Now, that would be our final answer. Now, you can also solve this using logs, but this is probably much easier. If you did it with logs, you get a more clear answer, because obviously, this is not that clear, but it still works. It still gets you the full marks. So, this is an excellence question. If you get a final answer for the rate, that's an excellence. Merit is you've made some progress towards an answer. Maybe you're finding an equation, so probably somewhere around here. And then achieved is just setting up a correct equation to solve, so probably this. That's a pretty generous question. Alright, now we're going to move on to this last question. Rearrange p to the power of 2x minus 3 equals q5x to make x the subject. Alright, so this question's going to have logs involved because we've got these powers, so that just tells me we're going to have to use logs at some point. What we're going to do is we're going to take this bracket and we're going to put it in the back. So 2x minus 3 log p, the p goes to the front now, and that's going to equal, this 5x will become at the start 5x log q. Alright, we're just moving stuff around pretty much. Now we can simplify that to 2x log p minus 3 log p equals 5x log q. Okay, now I want to get the x's all on one side, so we're just going to take this and move it to the other side. So 2x log p minus 5x log q equals 3 log p. It becomes a positive now because we've moved it to the other side. So now we're going to factor out this x. So x 2 log p minus 5 log q will equal 3 log p. So now it's just x equals 3 log p divided by all that what we just had, 2 log p minus 5 log q. And that's it. That's all you need. It's a pretty simple excellence question. Just need to know when to use logs and moving stuff around, but it's pretty generous. Getting a final answer in terms of x, that's an excellence. Mirror is, you're just putting the x's on one side, so probably here, mirror it. And then achieved is just taking logs of both sides and multiplies them both, so probably somewhere around here. Okay, that's question 1 done. Yeah, question 2. I'll do question 2 in another video, but that's all of question 1 done. So I've run through everything pretty clearly, I hope. And yeah, any questions, leave a comment. And yeah, hope you learned something. Cheers.